Okay, so sketch the set of points in the complex plane that satisfy this. So the argument of this is between 0 and 3/4 pi. Well, this tells me that I want to move to the left 1 unit. So we're going to say that's at -1. The argument's between 0, there's 0, and 3/4. Well, if we imagine we've gone this way, so that's pi on 4. And we want everything in there. Okay, so it's important that you give them the angle and you give the point. Okay, now write down inequalities in the modulus and argument. Okay, so if we just think about this blue dotted line, that's the y-axis or the imaginary, and we want the imaginary of z, since it's dotted, to be less than 3. The pink line, we want the real part of z to be less than or equal to 3. The argument with these two, even though the axis doesn't look quite right, it's actually pi on 6. Each one of them it's split equally into 30, 30, and 30. So that's also pi on 6. And that's also pi on 6. And pi on 6, pi on 6, and pi on 6, as you know, adds up to pi on 2, which works. So we want the argument to be between pi on 6, and they're solid lines, so I'll put that, and it's based at 0, which is nice, and 2 pi on 6, which is also pi on 3. Okay, so the set of points in the complex plane that satisfy this can also be written as this, and I can rewrite that as y equals -2x plus 17. So let me make a quick sketch. We've got a point here, which we know as AB. We have a point over here, which we know as 3, 1. And we know that the dotted line in between these two has the equation y equals -2x plus 17. That's what they're telling us. So there's a few things we know. We now know that the gradient of that line, so m has to equal 1/2, because this is the perpendicular bisector. We also know that the black line has to have the equation y equals 1/2x plus something. Okay. And we know one of the points that it definitely lies on. It lies on 3, 1. So I can use the fact that 3 equals 1/2x plus 1. No, sorry, plus c, I apologize. Let's try that again. 1/2 plus c, to know that 2.5 equals c. So I know that now I know my black equation is y equals 1/2x plus 5/2. Okay. Using that, I know that b equals 1/2a plus 5/2. I'm going to call that equation 1. Now, what else do I know? Well, I know that the gradient of this line is 1/2. So why don't I use that? Why don't I use y2 minus y1 over x2 minus x1 is 1/2, and there's equation 2. And if I solve 1 and 2 simultaneously, remember I've got a class pad. Okay, use it to your advantage. You don't have to be sitting there trying to chunk through the algebra for it. You can. And sometimes it's good practice. We discover that A is 11 and that B is 5.